Hello, everyone. Thank you for tuning into today's episode of What's New in Data. We have an awesome guest today, great technical and real world industrial background in AI and machine learning. We have Ozan Kabak. Ozan, how are you doing today?
Good, good, John. How are you doing?
Great, great. Yeah, happy we're finally able to do this episode. We've been talking about it for a while. I ran into you at Data Council in Austin earlier this year, where we originally had the idea to catch up on a pod episode. So good that we're here now.
Yeah, yeah, super happy to do this. And yeah, we have been planning about, you know, a discussion on all the cool developments in our space, but never got the chance. So finally we can do this.
Exactly, and I'm definitely in that time frame. A lot has changed as well. So in the landscape of data and AI, so definitely very timely that we're able to have this conversation now. Before we get into those topics, tell the listeners a bit about yourself.
Sure. Yeah. I think I can say that I'm a computer nerd from a very young age. I kind of started like hacking my way with QBasic when, we had MS-DOS stuff. And anything about computers, systems, programming, all of these things, it's a passion for me. I In terms of my career, I did my master's and PhD at Stanford, and during my time at Stanford I got introduced to the notion of dynamical systems, time series data. How do we observe dynamical systems? How do we apply algorithms on these systems like AI and other like data processing algorithms and all of that. So that's how I kind of got into this world of data and AI. And actually, my first job out of graduate school was at Stream, where you and I worked together, and that's how we know each other. And that was my, I guess, foray into like the data infra world, right? And I really liked it because I was coming from this like academic and like algorithm focused worldview, right? And then at Stream, I had the chance to really apply all of that in a more like how do we deploy this kind of perspective. So that really enriched my view of how to create systems. And ever since then, I've been working on data systems, applying AI on data streams, trying to create more and more efficient data infrastructures and thinking about algorithms in this space. So that's basically who I am. I am a data and AI practitioner who came in from the academic side of the world, and I've been in the practical side of the world for the last 10 years.
Yeah, and like you mentioned, you worked at Stream. We were colleagues, and I was always very impressed. You know, from the time you arrived at Stream, you were a PhD in electrical engineering from Stanford, but just how quickly we were able to dive into some real world industry problems. And since then, you worked at various companies, including Facebook, where you worked on Instagram signals, and
Mm.
now you're the founder of your own company, which is awesome. But love seeing people I've been connected with for a long time and go into entrepreneurship, but some really exciting stuff that you've been working on, and especially exciting with the growth and demand for AI and machine learning as commercialized products that teams can leverage for their own use cases. So given all that's going on in the industry, where do you think we are now, like the current state of developer technology for AI?
Yeah, you know, I think a good introduction into this whole where are we kind of analysis is probably through what people are talking about. And one of the buzzwords that you're probably hearing all the time is like AI native, right? AI native X, AI native Y, AI native applications. What does that really mean? Like, okay, it's a buzzword, but like everybody is probably having different things in their mind when they say AI native. Obviously, there's no consensus around this, but I think we are right now getting into a point where, at least in certain contexts, people have a agreed on understanding of this. In our space, in data infrastructure, I kind of think I liken the buzzword to cloud native, right? And what I like about this analogy is when we are developing any software service, we obviously think about the business logic of the service, right? But then we also think about a lot of externalities, like where is this thing gonna get deployed? How is it gonna scale? Do I need to wrap it inside some auto scale mechanism? How do I do load balancing stuff, right? Like, because if it's scaling and there are multiple replicas, how do they share the load? And then, like, how do I cache? Like, well, what role does caching play in this? How do I collect metrics from this? So these are things that we think about, and it has nothing to do with the business logic of the service, right? The actual code that you write. But I would find like 60, 70% of my time would go into these things, right? And now we have cloud native, and if you actually conform to a manifest, right? And if you containerize your business logic, all of these things come very cheap. They're abstracted away from you. I think AI is going through such a period. Right now, we are thinking about a lot of things when you're developing an AI application. We are thinking about training versus inference. Like, where does inference take place? Do I need a separate infrastructure for inference? Where does training take place? How often do I need to, retrain or fine tune this thing? How do I know when I need to retrain or fine tune this thing? How do I observe my models? So all of these things, again, like they're they cut across all kinds of different applications, right? I haven't discussed any business logic at all. Yet probably like more than 50, 60% of our time goes into these things. And they're still very fragile. Like, we spend a lot of time on these things, but they're still very fragile. I think when we arrive at the AI native infrastructure, just like what Kubernetes did in cloud native, we will not need to obsess about these things anymore. Like, most of these things will be abstracted away and there will be contracts. And if we actually abide by those contracts, all of these things will come for like free. And that's actually what we happen to be building at Sinada. Like, it's obviously like a very large mission. And it's not like one startup is going to solve it all kind of mission. But I think I'd like to think that we will contribute to this general trend towards the AI native data infrastructure. So it was a long answer to your short question, but in summary, I think building AI applications today is hard. You need to duct tape a lot of things together. You need to maintain a lot of different data infrastructure to support your application. You need to think about dichotomies like batch and streaming. You need to think about observability. You need to think about retrains or fine tunes. You need to think about triggers. You need to think about internal dashboards to monitor these things. So today we are super excited and we go through all of these complications. But as the technology matures, people, I think, will want a more unified infrastructure for these things.
Yeah, and one of the things that you mentioned to me was, the bifurcation between AI infrastructure and traditional data infrastructure, whether it's, in the cloud or in on-premise environments. So where do you see teams adopting AI infrastructure? Do you see mostly fully managed services or deploying on their own cloud bare metal, but more GPU based systems that could be, obviously higher costs and a little more scarce?
Yeah. Well, I think there's going to be a transition. I think people are going to get started with all these like AI clouds, right? And make API calls for everything because that's what you need to do if you want to get going quickly today, right? But I think over time, people will actually want to have more control about these things. And so there's gonna be a migration from, oh, let these XYZ companies, let OpenAI, let Hugging Face do all of these, and I'm gonna make an API call. So people will do that for a while, but eventually I think people will they will have their own compute. What's interesting is today there is a this bifurcation thing is actually quite interesting. Like think about traditional data processing systems like Spark or Flink, things like that, or what we worked on together at Stream. They're all like these CPU based compute technologies, right? Like at the end of the day, okay, they're distributed and they have fault tolerance. So they have all these like fine features, but the types of computations they are doing is like let's group by stuff together and let's order things and window things. So this is what I call like the traditional CPU based compute. So this comes all the way from database systems, right? And then now for AI, we have this GPU based compute, which has nothing to do with this. It's
Mhm.
just about arrays and tensors and linear algebra operations on these things. And the hardware is also very different. Like, what is a GPU? It's like a huge collection of processors that are very good at doing these kinds of linear algebra stuff and nothing else. So the traditional compute engines that we worked on over the last 40, 50 years as like engineers doesn't really do this stuff well. We have hardware that do this kind of like tensor manipulation very well, but like we don't have um, engines in the sense that they do both this kind of tensor stuff and traditional stuff, and I don't need to think about which engine I'm going to use for what. So we don't have just like one compute. Like if I'm gonna do traditional compute, I have Spark or Flink. If I have tensor stuff, I probably use some sort of distributed, ray like thing, and then it runs something like Torch underneath. So these are very disparate worlds, and they needed to be like because they were different things before. But at the end of the day, they are all transformations. So I think at some point we are gonna have compute abstractions where I will not need to do things at separate places. So I think there's going to be a lot of interesting tech in that space too, like in this unified compute space.
Absolutely, and when you say transformations, you're really getting at, going from raw, maybe unstructured or just data that's not useful in its current format to making it something that's ready for the business, whether that's, an an ML generated alert or a report that summarizes data or something that's interactive like an AI application where you can do some natural language chat type experiences with the data itself and get some insights. And that's really, it's a problem that, companies have been solving for decades now, but the technology and the art of the possible has just, really accelerated in the last obviously over the last 10 years with, cloud infrastructure, but now over the last 1 year with the AI, it's become a much faster pace of innovation going on. And I think teams are kind of struggling to see, what's the best way to adopt it because it's changing every month. And like you said,
Yeah, it's
uh,
very hard to keep up, man. Like
yeah,
2 months ago, like when if you wanted to generate some kind of like a image from some text or like some start from like a template image and then make AI fill in the gaps, that would take a lot of inference time. Now there are startups who can give you this real time image generation experience. So they actually one of those startups, the founders are our friends, Fall.ai. If anybody is interested in the audience, go check them out. They're a very cool company. But the thing is, like 2 months ago, nobody was like, people were imagining it, but it didn't exist, right? Now you can actually make open like some sort of channel and then you can stream AI generated images with 30 frames per second. So the pace is very fast. Yes.
yeah, absolutely. And the with the pace of innovation is very fast, and then of course the demands from the business are also accelerating in terms of knowing that AI is available and being able to actually see AI in their business facing operations, whether that's customer facing experiences where people want to give AI chatbots to their end users, or internal operations where AI is making smart decisions from your data automatically. Of course, there's risks there too. I mean, there's already a lot of examples on Twitter of, companies rolling out chatbots and they're just terrible experiences that, if you give it the wrong question, it'll completely give you some bogus answer, which is kind of looks negatively on the brand. I mean, people end up making fun of the
Yeah.
actual brand as a result of that. So, what's your advice to, data teams and engineering teams that are embarking on the journey of deploying an AI application for the first time? Because there's so many of them now.
Yeah. Well, definitely I would advise to go only don't go too fast when you're trying to go too fast, because what you said will happen, right? Especially today, I see a lot of like AI based customer support kind of deployments with the RAG and all of that, right? So these in theory sound very good and they are good. But if you do not take the time and if you do not actually back it with a good data infrastructure, which allows you to fix problems very quickly, fine tune your model as soon as you discover those problems. What I mean is like having a data infrastructure that supports human in the loop, right? If you don't have this kind of a infrastructure that backs these AI applications, you're taking a risk. And I mean, there are some contexts where like you can take this risk. It's okay. The world will not fall apart if you have a problem. But sometimes, especially like if you're doing customer support and something funny happens, people are going to share it on Twitter and then, the brand will suffer and all of that. So like you need to be sufficiently, I guess, careful when you're doing these things. And you need to have a good infrastructure to support these things because you're going to iterate a lot. Like this today, at the current state of technology, AI driven data applications need a lot of iteration. And you will need to do a lot of those iterations when the thing is live. Right. That's something you have to prepare for.
Mhm. Yeah, almost sounds like the AI operations will need their own production engineering team, to make sure that there's constantly fine tuning going on and monitoring the system. My perspective on rolling out AI is if your team, especially if your company is new to rolling out AI based applications, is start with your public facing data for an internal audience, right? Understand all the the caveats of deploying an AI system, but very minimal risk because if the system, let's say it leaks data, it's already public, and your end users are all internal, so that's okay. And then really just, you know, take more risk over time. And it might be a 1 to 2 year cycle where you incrementally add more risk and eventually make it, public facing experiences on, customers' private data. Like, hey, let's say, I work with a bank and a bank gives me a chat application that's telling me about like my account. That's actually like a lot of risk to deploy something like that because now your AI, your whatever it is, your vector databases are indexing and generating embeddings from private customer data and building experiences for that. That's something where hallucinations can be catastrophic, right? So I do think that teams just have to phase out how much risk they take and start small. Start with the least risky project where, the worst case scenario is someone internal raises their hand and said, "Hey, this looks wrong." And you have a human in the loop that's monitoring everything. Because you're also seeing cases where, there's already lawsuits coming up over, AI driven experiences. So yeah, the technology is amazing and it's moving very fast, but like you said, it's you definitely don't want to move too fast.
Yeah, definitely. A lot of companies are like deploying these things in this kind of support context because all of their support documentation is already public, right? So they actually kind of follow your advice. Where I think they get too excited about is like having these support support document trained LLMs interact with the customer directly. That's probably where they go too fast. I agree with you. I would first really like roll it out into an internal audience and then graduate it to the general public over time. That's what I would do.
Absolutely, and yeah, I that it seems the best way to sort of get your groundings in AI as a business, because yeah, the technical part's there, and people are going to arrive at similar conclusions over time, but ultimately you want to phase it where you know your organization is not burned by AI in the process, because it is great technology, and you want to make sure that you're always building positive momentum there. So there's another very exciting project that you're very closely tied to in the open source community called Apache Arrow. Can you talk to us about that?
Yeah. Well, Arrow, yeah, Arrow is a very interesting project. It sort of came out from, well, it has two origins. The first origin is, everybody like 5 years ago, let's just roll back time 5 years ago and think about all the different data formats and file formats and, you know, conversions between formats. And we would have like at the start of this whole modern data stack movement, what did we have and how did it progress, right? If you think about all that journey, there was like this huge interoperability problem, right? Like a new tool is coming out every day and everybody's storing data in a different way. And unfortunately, it's very hard to build an end to end data application with a single tool, which means you will need these things to integrate to each other. And then the question is like, do I need to convert and deconvert between all of these different formats? So we had that problem, the interoperability problem. And Arrow kind of came out as a solution for this problem. So, like, let's gather all the best practices from how to store data in memory, how to ultimately convert it to files, in which in this case is Parquet, right? And if we can actually gather all these like best practices, then everybody can just focus on the actual like processing that they're doing on the data and just agree on error once and for all. So that's obviously a good idea, like any kind of standardization idea. But then Arrow also has origins in this whole column storage, columnar processing way. So this has been going on for a long time now. Probably had the most momentum in the last 2 decades, right? And Arrow kind of integrates a lot of good ideas from that space of ideas as well. So the ultimate end result is okay, we have this me- memory in memory layout, which is a columnar, layout, and then it takes all the best practices and it plays very well with storage formats with like Parquet. And now you can just if you take in any kind of like C++ implementation, Rust implementation, whatever implementation that you need for your own data project. You don't need to consider yourself with this kind of stuff. So that's fantastic. And obviously, once you have that as a next step, people started to create projects on top of Arrow. And one of the projects that I'm super excited about is called Data Fusion. And Arrow Data Fusion basically is a it is a query engine at the end of the day. So, the audience of this podcast knows probably very well what query engines are.
Mhm.
But what's new about data fusion is that it's a deconstructed query engine. So typically what we want from query engines is like high performance, right? And we want them to be able to run as many different types of SQL queries as they can in the fastest way possible. And to achieve that, programmers and engineers who build query engines typically come up with very tightly integrated designs, right? So though very efficient code, and it runs very fast, very high throughput, whatever. If it is a streaming engine, maybe a very low latency, depends on what you're building for. But to achieve all of that, you end up with something that's very hard to extend. So you typically use it as is, and if it doesn't do the job for your use case, you search for some other engine. So data fusion is kind of like an antithesis against this.
Mm,
So it is trying to do what LLVM has done in the programming language space. And this analogy between data fusion and LLVM is due to Andrew Lamb, who was Arrow's PMC chair last year, and this year he's still super active. And I collaborate with him daily. Great guy. Anyway, so what Andrew says is, if we can deconstruct the experience of building data systems, and if as a engineer, if I can isolate myself from, oh, if I need to support SQL, how do I parse it? How do I create a logical plan out of it? How do I insert my own logical plan stuff in this engine? How do I optimize this kind of plan? What happens if I need a specific optimization for my use case? How does this thing get translated into a physical plan? Again, how do I do optimizers? Blah, blah, blah. So all of these things were very tightly integrated before, but the deconstructed data system idea is that if I actually have different components for each of these steps, and each of these components are modular and changeable, extensible, right? Then I can create families of query engines from a template. I have my DSL, I optimize for this, whatever X kind of data. I have special operators, you know, to do very efficient whatever operations on this data. Now I don't need to replicate 80% of, you know, the stuff that I'm not changing, and I can only focus on the 20% of the stuff that I'm changing. So this is very similar to how LLVM transformed the programming language, right?
yeah. And
Creating it,
and and
but
just
it's
for the
really hard.
listeners, LLVM is a language compilation framework. You may have a better definition than me,
Yes.
but
No, I think that's
essentially what it does.
that's
Yeah,
pretty good. Yeah.
so it helps you essentially build programming languages and handles the compilation and the lexer, parser, etcetera. And you're saying that, you know, Arrow and data Arrow essentially gives you a query engine creation framework, correct?
Yeah, yeah. So Arrow is the base layer, like data format, and Data Fusion gives you this query engine creation framework. So I really like this analogy, because if you think about, you know, IDEs and programming languages before LLVM, like we had like Eclipse and that's it, right? Like an
Mhm.
IntelliJ.
Yeah.
Okay. And now we have like this VS Code and LSPs and all kinds of plugins, and everybody's creating their own language. It is so easy, right? Because now what used to be a gargantuan task of creating like these compilers and all of that, now it's not that hard. You just change what you want to change and that's it. So data fusion is trying to do the same for the experience of building databases and compute engines and all of that, right? So I'm very excited, because I think if this trend really takes on, people will be able to make a lot of like custom made systems with very little effort, and optimize for their use case, and roll out, these kinds of technologies very easily. So like imagining this VS Code, like, proliferation of all different engines kind of thing in our space is very exciting to me. And, the natural question is why, for example, my company Sinara is betting on this, right? Like, okay, this sounds good, but why? Well, if we go back to the AI native data infrastructure, how do you make that real? Like, we have specific ideas on how to unify batch and streaming. We have ideas of how to integrate AI models into compute pipelines. So either I need to reinvent everything that Spark does today, right? Which I cannot do with, a small amount of money, right? Or I need like an extensible query engine creation tool, like data fusion, so that I can do this. So that's why like I'm personally very excited about data fusion. I think it's gonna create opportunities for a lot of data entrepreneurs to create all kinds of different technology.
Yeah, and it's powerful technology, and I think the great thing with Arrow and data fusion is, it is making it more accessible for, you know, more innovation to happen in the market because, traditionally, query engines were proprietary, kind of black boxes where, it was commercialized and expensive. You had to buy, a database. You didn't really know anything about the underlying query engine. Then you had, open source databases come out where, yeah, you can build on top of the database. Now you have like a framework to build your own domain specific query engine, OLTP, OLAP, whatever you want
Sure.
to call it, using open storage, which is another innovation in its own, category, right? The fact that
Yeah.
you have this cheap, you know, on cloud native, you can store data either locally on files. Sorry, I use the buzzword cloud native, but it's actually not cloud native, but works very well with the cloud, storing in S3 buckets or GCS buckets. And you have this, things like Parquet, and you can essentially build your own columnar storage format for super fast OLAP queries. So, there's a lot of room for additional, innovation that's going to happen over the next 5 to 10 years with, like I said, sort of these domain specific data processing engines. So I think, and you're applying this at Sonata essentially, and you're also a big contributor to the community. So you're also helping others
Yeah.
innovate along the way and build their own, sort of domain problem solving specific, data processing products that will be, kind of commercialized for very specific use cases. So it's super exciting. I think that, we were sort of, I remember when you were at Stream, the big things back then were, Apache Storm, and Flink was very much in its infancy. We were aware of
That's
Flink,
right.
but
Yeah.
yeah, at the time Flink, didn't quite have, a lot of the stream processing features that Stream had. But now Flink has obviously grown over the years and gotten a lot of adoption, and Hadoop was very popular. But now it seems like, okay, now instead of, you being handed this kind of open source data processing engine, you have the framework to build your own, which is awesome.
Yeah. Yeah. Just the other day, I saw a project using data fusion to build a bioinformatics specialized query engine. Like, how cool is that, right? Like, at Sinara, we're doing this AI native data infra stuff, and the same base layer technology, it is so modular and extensible. Somebody else is using it for bioinformatics. So that's the kind of future that I see. Like, people will not need to reinvent the wheel in terms of these like compute engines anymore.
Yeah, it is very powerful. I think it's also going to be great for, the both commercial and academic and research purposes. You know, you made the comparison to LLVM, and LLVM was obviously very popular in programming languages courses. It came up in mine, when I was a student, and I think it's great to see this now being offered to people who want to build, data processing products. So, we'll definitely see where that goes. Definitely excited to see, how Sonata is able to apply this and roll it out into your own products, and we'll all be, very, very excited for those announcements. But I also want to get your take on, your vision for the future of AI.
Yeah, sure. Well, this is a thorny topic, right? Because there's this huge debate between AI is gonna kill us all versus, no, AI is not gonna kill us all, camps, right? So let's get that out of the way first. But I think AI will not kill us all. I agree with basically what Jan LeCun says all the time. I think, yeah, all the developments are very cool. It's gonna impact economics. It's really going to have a huge impact on the world, but I don't think Skynet is coming soon. I'm not saying it will never happen. Okay. I mean, like, because the pace of progress is very fast, but I think there's, we do not need to lose sleep over it just yet. That's what I'm going to say. So with this out of the way, let me discuss more like practical aspects of, what the future holds. I think if you're following the miniaturization efforts in the open source to get smaller and smaller, models that have similar generative capabilities. I'm a huge fan of this. Who isn't? But I think that's really gonna keep going. And I think that will unlock a lot of the use cases. I think in a few years we'll do we'll go through maybe like a few algorithmic innovations, innovations on how we train models, innovations on topologies, innovations on you know, distilling the models that we already have. So all of those, I think, will synergistically result in much smaller models, and we will be able to deploy these to edge systems, phones, and this and that. And I think that will unlock a lot of use cases. And we're seeing this already in computer vision. Like if you look at the recent LCM stuff, right? Like that's how like people can do this real time image generation now, because you can do inference under like 100 milliseconds now. So that's gonna keep going. I think we started off with very large models because we somehow figured out how to train very large models. I don't think we need that many parameters. I have a I don't want to say I have a firm belief, but if I have to take a position, make a bet on whether we actually need like this many billions of parameters, I would say no. I think we'll eventually figure out how to do these things with fewer parameters, not like 10,000 parameters. That's not what I mean. But like we don't need that many parameters. So I think those efforts will keep, bearing fruit, and we are going to unlock a lot of new use cases. We have some work in Sinara towards this as well. I don't want to discuss this out like very publicly, but this is a personal interest area of mine as well.
Mhm.
Um, so I would say anybody interested in how the space is going to evolve to follow, what the model sizes are doing, right? I think that gives you a lot of cues. And then the second thing is maybe this is a little counterposition to the typical Silicon Valley thing right now, but this whole GPU rich, GPU poor stuff that may not last for very long. I think as these models get smaller, and if we make a few algorithmic innovations on the way, we will not need this big of a compute power. I mean, we will still need the big compute power, but not as much as today, I think. And I kind of liken this to Cisco before and after the dot-com bubble, right? Like they like everything was about stronger routers and like network equipment and this and that, and then turned out the value was not really there after the dot-com bubble. And Cisco, it's still a fantastic company, obviously, but like it never had the same standing in the market anymore. So now, okay, people think about like all these GPUs and GPU makers and all of that. And I think that's going to keep going for a while because we don't know how to do otherwise today in terms of creating good models. But I think at some point, this is going to pass. GPUs are always going to be very important because at the end of the day, this is just linear algebra. All AI
Mhm.
is linear algebra. But it is not going to be as much of a bottleneck as it is today. So that's I know this is a little counterposition to what people are talking about these days, but well, we come out to podcast to say somewhat controversial thing, don't we?
Absolutely. And, it's definitely a great perspective that, miniature models, they are growing in their applications. You know, we're, you know, I'm very excited by the work one company is doing called Hyper-B. They have some great performance on Hugging Face, and you'll see, other examples in the market as, more demand comes up for miniature sort of portable models that can run on, more commodity compute that's lower cost and sort of purpose built for specific use cases. Just to entertain your other point that you kind of glossed over, which is, will AI kill us? I mean, what's the just to humor me, what's the argument there that AI is actually a threat to us?
I mean, if anybody is curious about, this and the audience, maybe a good person to take a look at is Eliezer Yudkowsky, right? Like he has been
Mm,
talking about these things in the less wrong community for a very long time. And he has a lot of articles about, you know, why he thinks this is a possibility. And if you actually remember, like when there was a call for moratorium on AI development, right? I think a lot of that kind of came out from the intellectual work of the less wrong people and Eliezer Yudkowsky. So I would advise anybody curious about this to take a look at that. I think Elon Musk mostly, my understanding of what he says is like he also thinks that this is a possibility. I'm not sure if just scaling the models that we have today is gonna give us that. But I think what their argument is this whole notion of emergent capabilities, right? Like
mhm,
you think about an LLM is not trained specifically to be great at, let's say, translating from language between languages, right? They don't do it. But it turns out if you have a very large data set and if your model has large enough capacity, just by training it on this, predict the next token kind of thing, actually gives rise to this emergent capability of translation, right? And right now, I think we have some ideas about what kinds of capabilities are emergent versus what kinds of capabilities you need to specifically train for.
mm,
For example, it seems like arithmetic is not emerging from predicting the next token. So we know that certain things are like more on the emergent side and certain things that, oh no, you have to actually teach the models these things. Or like we haven't found a simpler rule out of which these things emerge class, I would say maybe.
yeah,
But I think what scares people is this whole notion of emergent capability, right? Like if now we discovered a certain simple rule by which if we train models, other things emerge, maybe in the future things that we don't expect are gonna emerge, right? I think that's the one of not I wouldn't say that's like the key idea of like AI may kill us whole thing, but I would say that's one of the factors why people think it could be dangerous. Things can emerge out of this that we didn't expect, right? Because it has happened before, like this the example just I gave, right? Like so this thing called emergent capability exists, and they are I think afraid that reasoning may be an emergent capability too.
yeah.
Right.
It's fun to talk about. It's more, science fiction at this point. It's not.
I agree. I
Yeah,
think I mean Jan LeCun also says that. He says it's no, that's not going to happen that way. I agree, but I don't want to be like overly confident about anything because in this space things are moving so fast.
yeah.
Anything can happen, man.
Yeah, yeah. I think there's the other scary one, which at the same time fun to talk about is the idea of like collective intelligence, where emergent AI can actually, multiple agents can start collaborating, and they can communicate over networks, and they can plan things together and distribute tasks and all that sort of stuff. But yes, I think that's sort of futuristic. It's sort of sci-fi. There was a fun book on that topic if you just want to read that viewpoint from Nick Bostrom as well, Super Intelligence, which I think Elon Musk it was a tweet is actually the one where I came across that book, and it was entertaining actually. So, but I not that I believe that in that viewpoint that AI is going to kill us, especially seeing some of these, the current state of AI, but But yeah, like you said, it's moving so fast. You don't want to make any declarations of how the future will actually play out. Well, Ozan Kabak, CEO and founder at Sonata, and you've done a lot of great work in machine learning and AI over the years. So great to have you on this episode of What's New in Data. And thank you to all the listeners who tuned in. Ozan, where can people follow along with your work?
Yeah, well, two places. Definitely go visit the Data Fusion GitHub. It's very active, and we would appreciate more stars and more people checking it out. Obviously, it has a very fast pace. A lot of commits are coming in. Play with it. Give us feedback. We want to make it better all the time. Use it. We'll be very happy. So that's venue number one. And if you're curious about like what we mean by AI native data infrastructure, unification of batch and streaming, and seamless, you know, integration of AI into compute, what's gonna replace Spark? Like, what's the next generation Spark? If you're curious about these things, check out Sinara.ai. And if you have any questions about what we do and what our ideas are on like what's gonna replace Spark, just shoot us, an email, join the Data Fusion Discord. We are super excited about, all these technologies, and I will be happy to be in touch with any practitioner who wants to, discuss these things.
Thanks so much, Ozan, and thank you to everyone who tuned in today.
Thank you.